Hey everyone. This week we are looking at Chapter 12, Technical Definitions and Descriptions. As you're doing writing in your field, oftentimes you will find that the people that you're writing for have a lot less knowledge of your topic than you do. It's typically a layperson, such as myself, while the report that we're doing now, the formal report, will not be targeted to the layperson. Oftentimes, again, your writing will be for that person. And a layperson or a person who's not as familiar with things will need concepts, equipment, and processes described for them in more detail than somebody who does have the same amount of knowledge as you. And to do that, you'll need to use technical definitions and descriptions. So there are three different kinds of technical definitions: parenthetical, formal, and extended. And then there are a couple different types of technical descriptions. There are mechanism descriptions and process descriptions. So let's first take a look at parenthetical definitions. So an example of a parenthetical definition: the anode, a positively charged electrode, you see that in parentheses, is attached to the, and then the loss of ice cover in the Arctic is reducing the region's albedo, the proportion of incident sunlight that is reflected back into space, and thereby increasing global warming. The island chain has several haul-out sites for stellar sea lions, but only one rookery, a haul-out site reserved for breeding. So in each of these, we have a parenthetical definition. Here, we actually have it in parentheses. Here, it's using the dashes. And here, it's after the comma. So just take a look here. Next, we have formal definitions, and those are also known as sentence definitions. These, you want to use them when something can't be defined in just a phrase, or when you're setting up an extended definition. These typically consist of three parts. So it's the term you're defining, Weimaraner. Then you have the larger class to which the object or term belongs to. Here it's a gun dog of German origin. And then what distinguishes, or the distinction, the object from the others in its class. So in this case, it's a mouse gray to silver gray fur and eyes that are blue in puppies and turn gray or amber in adulthood. And here are some other examples: terms, class, distinctions. Zoonosis, it's an infectious disease. The distinction, it can be transferred between species. So you can take a moment, pause it, and look through the different terms, classes, and distinctions. Some English classes in high school, or possibly in your 1001 or 101 class, you could have possibly done an extended definition essay where you expanded on a formal definition and used term, class, and distinction. So you might be familiar with this already. Some things you want to make sure you avoid would be circular definitions where the term and class are repetitive. That would be something like: an electrical insulator is a material for insulating, often made of rubber, glass, or ceramics. So to correct that, you would say an electrical insulator is a non-conductive material such as rubber, glass, or ceramics used to inhibit the flow of electrons. So there you've taken out the second insulating and changed it to non-conductive material. The next thing we're going to talk about are qualifiers. And qualifiers are basically parameters that we put around definitions to kind of rein those in. As we well know, there are words out there like love. If I say love, that could evoke so many different things. It could mean brotherly love, romantic love, I love pizza, I love lamp. There's so many different ways that you could interpret that word. So a qualifier would be something that we'd want to put into place there. If you've read academic research articles, I'm sure you've seen some of the broader terms with qualifiers, and you just may not have realized that that is what they are. Essentially, those are when the author says, hey, I'm going to tell you that I know that this is a really broad term, or I know that there are a lot of different ways that this can be used, but I'm going to tell you that for my purposes and in this report, here's how this definition is going to apply. So here's an example. In automotive applications, mechanical efficiency is the ratio of brake horsepower to the indicated horsepower. So that's a definition. This is what it's going to mean. In this report, the XM1232BA transition project will be referred to as the project. So you know that anytime you see something called the project in this particular report, that's what it's referring to. So the author is explaining these with these qualifiers. So it's fine to do that in your papers. So it's fine to say, hey, I know that this particular definition has multiple meanings. In my particular piece of writing, when I'm referring to this definition, I'm referring to this particular meaning. So you can't make up new and exciting meanings, of course, but you can indicate which particular meaning that you're holding in the highest regard. And also, if you are talking about multiple projects in a report, it's a good idea to say, in this report, I'm referring to this particular project as the project, and be clear on that. That way that the person knows that which one is the project. And then just make sure that you're consistent with that. That way they're not confused. And next, we're going to talk about audience appropriate definitions. So you want to make sure that your definition is appropriate to the needs and understanding of your audience. So let's take a look at a couple. First, wind power density is a calculation of the mean annual power available per square meter of swept area, taking into consideration wind velocity and air density. And then there's also wind power density is a measure of how much wind energy is available per square meter of the circular area that a wind turbine's vanes sweep while turning. Both of those are perfectly fine definitions. The first definition is a lot more technical. It lets the reader know precisely what factors are included in a calculation of wind power. It gives the average velocity of the wind and the density of the air at the wind turbine's location, so it's like altitude and humidity. But the second definition, it's more of a layperson's definition. It really just defines the term as a measure of available wind energy per annum, and that's how that energy is calculated. That's not really there, mainly because the audience probably won't care or understand. So that would be more like if you were writing for me. I probably, well, not probably, I definitely wouldn't understand. Not that I wouldn't care, but probably wouldn't understand. So unless it's absolutely crucial for me to understand that, it wouldn't even be necessary. So think about audience needs. Then there's the extended definition. Sometimes even the sentence definition doesn't give you enough information. And if that's the case, you're going to have to extend your sentence definition by any or several of the means listed on the next slide. Encyclopedia entries and textbook explanations of concepts, ideas, equipment, and so on, those are all examples of extended definitions. Extended definitions generally begin with sentence definitions, and then they're extended by appearance, because what's a better way to describe something and get people to recognize it than to identify what it looks like? I mean, if you think about it, if someone comes up and says, "Hey, have you ever had Professor Coster?" If we're in a normal face-to-face environment, if they say no, what does she look like? That's going to be typically the first thing. And I'm usually pretty easy to spot because I'm tall, bigger, and redheaded. So like 3 words describe me and boom. So for this, you would say appearance. A hydrometer consists of a clear glass tube with a rubber bulb on one end, a thin rubber tube on the other, and a calibrated float inside the tube. Typical dimensions: a hydrometer weighs. So right away, you can extend this definition and explain what a hydrometer looks like. The other thing you can do for an extended definition is do a comparison and a contrast statement. So some things are better defined by explaining what something is not. So sometimes a negative definition is useful if 2 things can sometimes be mistaken for one another. And a funny Canadian is merely an unarmed American with health care. So because of its rotary cycle, the Wankel engine has lower vibration than a reciprocating engine and is more free revving, allowing higher red lines. And this goes back to those definitions. I'm sure that made sense to so many of you. For me, it does not, but I am positive that some of you are like, okay, that makes perfect sense. So compare and contrast. Another way that you can extend the definition is through etymology. And this is how the word derived linguistically. The Wankel, or rotary, engine is named after its inventor, Dr. Felix Wankel. Encephalitis is an inflammation of the brain. The term is derived from the ancient Greek cephalus, meaning head. The prefix "n" for internal is added to refer to the brain, and the common medical suffix "itis" indicates an inflammation. So by breaking the word apart and analyzing each piece, then we can understand how the word encephalitis comes to mean inflammation of the brain. And that's through looking at its etymology. Similar to compare and contrast, sometimes examples help readers understand new concepts, and that's by relating things that are familiar to them. Sometimes other examples give concrete cases, and that helps kind of solidify those abstract concepts for us. And the formal term for that's exemplification, and it's just like it sounds. Exemplification sounds like example, and exemplification is just that, giving examples. A zoonosis is an infectious disease that can be transmitted between species. Rabies, for example, can be contracted by humans when bitten by infected animals. The hantavirus, which causes hemorrhagic fever, among other potentially fatal diseases, is generally transmitted to humans through contact with mouse excrement. That's what you came here for this lecture, isn't it? That exemplification. But at this point, you're pretty clear on what zoonosis is, right? I know I am. Another way we can look at extended definition is through function and purpose. So this makes it clear as to what objects are often created for a very specific function. They're identified with that function. Sphygmomanometer. So I say this, it's used to measure blood pressure, but typically we don't call it that. We just call it a blood pressure cuff. That's a lot to say. Because we associate it with its function and purpose. We can also extend the definition by associating something and providing its history. And of course, that's just the story of how something came to be and how it got to be in its current condition. For example, going back to the Wankel engine, which is now defunct. And here you have a little bit of its history if you want to pause and read, or if you already know, there's no need. Next, there's also the operating principle, and this describes how something works. So, since the operating principle and function are closely related, there are similarly useful ways to help readers understand tools and technology. So here we see a mercury thermometer operates on the principle that mercury expands noticeably when heated and contracts when cooled. So the top of a mercury column rises and falls with temperature when it is confined in a cylinder. Here we have an example of the basic operating principle in action using fusing. Fusing is the best verb to describe what fusion does. It's not a circular definition, but an identification of the basic operational principle. So nuclear fusion involves fusing small atoms together and occurs when two light nuclei collide to form a heavier nucleus. Next, they use a compare and contrast. Like nuclear fission, the reaction is accompanied by a significant energy release. Unlike nuclear fission, there is no potential for meltdown, there are no radioactive byproducts, and fuel is virtually unlimited. Next, they use exemplification. Nuclear fusion is the mechanism that fuels the sun, which is the solar system's largest fusion energy source. Then, to further explain it, they provide operating principles, 3 of them, and by the end of this section, the reader is clear through extended definition on what this is. Next, we have technical descriptions. So these help readers understand objects, mechanisms, or processes. These are often used in proposals, manuals, technical articles, patent applications, specifications, requests for proposals, and things of that nature. They're often used in their own right, for example, in encyclopedia entries. And there are a couple of types of technical descriptions. Mechanism descriptions, and those are objects designed for a purpose, and process descriptions, so steps or actions over time. So what is a mechanism? A mechanism is any system of parts, moving or not, designed to work together for a common purpose. And that could be a toothpick to a bombardier passenger jet. So it could be extremely simple to something extremely complex. So take a moment and take a look at this. What is it you're describing, and what is its purpose? What does it look like? How does it work? You want to keep that part brief. What are its component parts? Next, for each part, you want to answer the following questions. What is it, and what does it look like? Of what component parts, if any, does it consist? What is its purpose or function? How does it relate to, and how is it connected to neighboring parts? And then finally, how do all the parts work together to perform the operation of the mechanism? So describe one operational cycle. This might be a little bit hard to read. You can take a look in your textbook, and it should be better in there if this isn't easy to read. But this is the mechanism description. And then we have process description. So what is a process? And that's a series of steps or actions in time leading to a defined end state. In cyclical processes, the end state is the beginning state, still a defined state. Some processes are natural, tree growth, seasonal cycle, formation of mountains, and so on. Some processes are performed by humans, oil changes, heavy equipment manufacturing, and so on. But a process description is not meant to be followed. Those are procedures or instructions. The difference will become obvious in the next chapter. So here, you want to take the time to look at these questions. What are you describing? What is its purpose, if it has one, or outcome? How does the process function overall? What are its component steps? What tools and materials will be used in the process, if any? For each step, you want to answer the following questions. What is it and what happens in it? Of what substeps, if any, does it consist? What is its purpose or function? What happens in this step of the process? How does this step relate to the next step? And then here again, you can take a look in the textbook if you can't see the example very well. And that concludes Chapter 12. As always, have a great week. And if you have any questions, please reach out and let me know. Thank you.